start again? Okay, cool. Yeah, so the overview of this talk, I'm going to just cover the motivation and why we're doing this and the basics of the design of EIO. And then look at interoperability with some of the other IO libraries we've got. I want to draw out a few little differences between LWT and EIO, and then describe some experiences we've had porting existing software to use it. So one of the main motivations is to take advantage of the new effects support in OCaML'5. And having a direct style IO library using effects means we don't need any monadic syntax, which makes OCaML a lot easier for many beginners. It means you can use all of the standard built-in features of OCaML, like try, match, and while. It means very often you don't need a separate, like an LWT version, and an async version, and a plain version of your library. Very often just a single library will work everywhere. We don't need to use heap allocations to simulate a stack, which means EIO programs often run a lot faster than LWT ones, even on a single core. And having a real stack means that things like backtraces and profiling tools work. Our second goal is to support multiple cores. So LWT and async can only run on one core at a time. We have to use different synchronization primitives that are all thread safe in EIO. And finally, we wanted to fix a few annoyances that we found over the years with LWT while we're making a new library. So the basic structure of EIO, it's got lots of separate packages. The main one at the top is EIO itself, and then we have lots of backends, so a different package for each platform. And EIO defines 3 core effects that you have to support if you want to be an EIO backend. There is suspend, which a fiber can use when it can't make any more progress. It wants to yield to another fiber until it's ready. Fork, which creates a new fiber. And get context, which allows you to get some sort of fiber local state. And if you write an effect handler that implements those 3 effects, then you are an EIO backend, and you should work with EIO software. In addition to that, in the EIO package, we also define a whole load of module types for operating system resources, things like networks, directories, and files. And that's because if you have 2 backends that, for example, both provide networking, we really like them to use the same interface. So that's why they're all in there, even though not all backends use all of them. So the main sort of backend, I guess, is EIO POSIX there in the middle. And this, when you do IO operations, it makes system calls, just like LWT Unix does. But we also have other options. EIO Linux, for example, uses IO uring. So when you perform operating system actions, it's actually just writing actions into a ring buffer that it shares with the kernel, and they get executed as a batch. There's also EIO Windows, which is well, similar to EIO POSIX at the moment, but adjusted for Windows. And if you want to target one of these particular platforms, you can just target that backend. So you can actually program against EIO Linux and use all the cool features of Linux. Or more commonly, you want to write a cross-platform application, then you will target EIO main, and that will select the backend for you automatically and give you a slightly more restricted API that's common to those platforms. And all of those 3, Linux, POSIX, and Windows, these are sort of traditional operating systems, and they all actually implement a slightly extended version of the EIO APIs defined in EIO Unix. And that's basically EIO APIs plus file descriptors, which is useful for interoperating with other libraries using OCaML's Unix. But in addition to traditional operating systems, we also have some other backends that work differently. We have EIO.js for JavaScript that allows you to run EIO programs in the web browser. And we have EIO Solo 5, which is useful for unikernels. So if you want to run EIO programs without having a traditional operating system at all, just running directly on top of a hypervisor. So why might you want to use EIO? One reason is performance. So this is a little benchmark we saw in the tutorial yesterday. We're opening /dev0, and we're reading bytes out of it one at a time using a buffer. So we're only occasionally making system calls, but and I think we're reading about 100 million bytes here. And we can see in the EIO code at the top, this takes 0.38 seconds. And doing the same thing at the bottom using LWT, as well as the code being a bit longer, it takes 1.49 seconds. So nearly 4 times faster. That's just the benefit of using effects and being able to use a real stack. Of course, multi-core performance is also important to us. And over the last year, one of the things we've been doing is converting the synchronization primitives from using mutexes to using lock-free programming. And this can have quite a big improvement in performance. So the bar, this is a graph showing the performance of synchronous streams. So you've got a producer and a consumer, and when they're both ready, they exchange a value. On the left, we've got the case where they're both running in the same domain, and that got a tiny bit slower when we moved to lock-free. But in the other cases where you have multiple domains, where the sender's in one domain and the receiver's in another, or there's multiple senders and receivers, you can see we get a lot less contention and much better performance. Okay, so that's some reason why you might want to use EAO, but of course we've got a huge amount of existing LWT code, and we need to be able to support that. So we have another package called LWT EAO, which allows you to run them at the same time. So and as we saw in the tutorial yesterday, you should be able to take any LWT program, find the call to LWT main.run, and you replace it with these 3 lines of code. And the first one starts the EAO main loop, so you can use EAO features. The second one starts an LWT main loop that just delegates to EAO when it needs to block. And the third one switches from EAO context into LWT context because the rest of your program presumably is LWT. And when you do that, you should find that your program continues to work exactly as it did before. All your tests should pass. But now you can use all the features of OCaML'5 and effects and EIO. And at any point, you can switch between LWT context and EAO context using these 2 functions. So if you're in LWT code and you'd like to run some EIO, you just pass in a function, an ordinary EAO function. It just returns a plain alpha value, and it will run that in a new fiber, and it will give you an LWT promise for the result of that fiber. And similarly, if you're running EAO code and you'd like to run an LWT function, you can use run LWT. The function produces a promise, and your EAO fiber will wait until that promise has resolved. Oh, we've lost the picture. Okay, yeah, so same situation with async. You can run EAO code from async, and you can run async code from EAO. This is a little bit harder because LWT has pluggable backends, so adding EAO support to it didn't require any changes to LWT. For async, we do need some minor changes to the library, and those haven't been upstreamed yet, but we do have a prototype that works. And you might be wondering, can I use all 3 at the same time? And the answer is yes. So we have an async EAO looped Chimera program example. We start an EAO loop, we start an LWT loop, we start an async loop, and then we run an application that uses I/O functions from all 3 libraries together to provide a service. And that's running all these 3 loops in a single domain, all scheduled cooperatively with each other. I wouldn't recommend doing it, but it does work. As well as those 2 libraries, there's also some OCaML'5 specific libraries we interoperate with. There's Domainslib, which is designed for CPU-intensive tasks. It schedules CPU jobs across a pool of domains. And KCAS, which we'll be hearing about later today, which is for writing composable structures that are thread safe. And these all support the domain local await protocol that Vesa has developed. So, for example, you can have a Domainslib function adding items to a KCAS queue and having them being read from EIO, and everything will just work. All right, so I just want to talk about a couple of improvements we've made over the LWT style of programming. One of these is about resource leaks. As we heard in the ML workshop yesterday, resource leaks are a big problem. And the way we solve that in EIO is with these things called switches. And the idea is when you have things that need to be cleaned up, they get attached to a switch. And when you turn off the switch, everything is cleaned. So at the top here, we have some EIO code for accepting a network connection. We create a switch. We accept the connection. And we have to pass in a switch here, which sort of defines the lifetime of that connection. And then if you want, you can close the connection when you're done, as usual. That's fine. But if you don't, you could just return from this function, and it will get closed anyway. And crucially, it will not only get closed in the happy case, but also if this crashes, if it raises an exception, or if it gets cancelled, this resource is also going to be cleaned up reliably. By contrast with LWT, it works in the happy case, but if that is cancelled, it's going to leak a file descriptor every time you cancel it. And then I think my favorite feature of EIO is the ability to easily get bounds on the behavior of your programs. So people often say with functional programming and OCaML, it's great because you can reason about your programs. So let's try reasoning about this program. What does it do? Does it use the network? Should I set up some firewall rules? And the answer is we can't tell. It might do anything. And you might say, well, Thomas, you haven't shown me the main function. Of course, we don't know what it does. But even if you read the main function, you'll probably find it just calls other functions, which call more functions that call into other libraries, and they call into further libraries. I may have to read literally millions of lines of code to know what this does, which is totally impractical. And even if I did, by the time I finished, it would take me so long, there would have been new releases of half the libraries, and I would have to start all over again. And the reason we have this problem with LWT is because it treats a lot of mutable state, like the file system and the network, essentially as a global variable that's accessible from anywhere. And as we know, global state is very hard to reason about. So EIO takes a different approach. When you start an EIO program at the top of your application, you get given this thing called env. And env represents the environment of your process. It represents all access to the outside world. And anything that the program does to interact with the outside world ultimately will go through env. So when someone gives me an EIO program that I've never seen before, and I want to know what it does, I immediately click on this env and let my text editor highlight the uses of it. And in this case, we can see this program, it's taking two things out of env is a polymorphic record. We're taking two things out of env. We're taking the network and the file system. Well, that's not very interesting. Lots of programs use the network and the file system. But then we can follow those things and see how are we using the network and how are we using the file system. And here, I'm using the network exactly once to create a listening socket on port 8080. And that immediately tells me that this program does not make any outbound network connections, and it does not listen on any other sockets. So I can immediately write my firewall rules. And secondly, we can see we're using the file system only to access this directory /serve htdocs. So immediately we know it doesn't read or write any files in any other part of the file system. And if you want to know more about the sort of theory behind that, there's a blog post called Lambda Capabilities, which goes over it in much more detail. So I wanted to talk a little bit about our experiences porting software to EIO. One of the big things we've done over the summer is porting the solver service that is used by OCaML CI. And what this does is every time you submit a pull request or something to GitHub, we need to know which platforms to test on. So we do an OPAM solve on each of the possible supported platforms. There are, I think, 68 platforms we can test on now. All different versions of OCaML and so on. And we had an OCaML 4 version that was spawning sub-processes, and we've now made that into an OCaML 5 version that just runs everything in one process. And that's made it massively simpler. It's about half as many lines of code for the multi-core version. And what I found very interesting about this was I found a bug while I was doing it. When you run it, you give it a command line argument telling it where you would like it to cache things it downloads from the network. And the thing that was actually downloading things from the network, it just forgot to concatenate that directory with the leaf. And so instead of putting it in the cache directory, it put things in the current directory. And I got access to the production server to have a look at it. And it turns out the server's running as root. And its current directory is the root directory. And I did ls/. And sure enough, that's where all the temporary files were. This kind of bug is really hard. This kind of mistake is really hard to make with EIO. Because if you want the caching module, if the caching module wants to write to the root directory, it needs to take the root directory as an argument. And it would be completely obvious that you're taking the root directory out of env, and then you're passing the root directory to the caching. That makes no sense. The one downside I would say about this, though, is we're running the new service in production. We're also still running the old version, and that's because the old version's faster. It's quite a lot faster. This has nothing to do with EIO. I have a reproduction case that doesn't use it. But yeah, it's not scaling nearly as well as we'd like to, so we're currently investigating that, and there's a bit of performance work to do. The second one I wanted to mention is a Wayland proxy. So on my computer, I use lots of virtual machines. I run most of my development happens in virtual machines, and I need some way for the windows in the virtual machine to be proxied onto the host, so I can use them alongside, all together. And I have an OCaML program that does that, and I ported that to EO, and that got about 100 lines shorter, which I thought was rather a nice result. And it's working very reliably, and it gives me a good motivation to to make sure EO is reliable, because if it ever crashes, all my windows disappear and all my data is lost. So, yeah. And then there's a whole bunch of other libraries that we've been porting, and these have really been pretty straightforward. So, for example, with OCaML TLS, it has a subdirectory called LWT. I just copied that directory as EIO. I added the bridge, the LWT EO bridge, as I explained earlier, and I can immediately check that all my unit tests still pass. And then I just went through it line by line, changing each line of LWT to EO, checking that the unit tests still pass at every step. And then when I get to the end, I remove the bridge. Now I have a pure EO library. And that's been working really nicely. So we've done that for TLS, we've done it for CoHTTP. We've got a port of Dream, which is even running on EO Solo 5 as a unikernel, if you like. There's Cat and Proto. Some of these aren't quite finished, but they are all working. So just to finish up, we're currently working towards an EO 1.0 release. And by 1.0, I mean reasonably feature complete. You're not immediately going to start hitting missing features. The main thing to do left is we need to finish up some of the file system APIs. We've got PRs open on a lot of that stuff that's going to go in. And the other really big feature, which unfortunately isn't in yet, is support for OCaML 5.1 events. We've got all kinds of exciting tracing stuff queued up in PRs. Patrick in particular and Lucas have been writing Meow monitoring for EIO, which is a Toco console style interface that lets you see exactly what your program is doing. And as soon as OCaML 5.1 is released, we'll be starting to merge that kind of stuff. So hopefully EO 1.0 in the next few weeks. If you'd like to get involved, everything happens on the GitHub repository at OCaML'/EIO. The README file at the top has links to various other things, including we have a Matrix chat channel, which is fairly active. And we also run developer calls every 2 weeks. So if you're interested in working on EO, or you're building software that uses EO and you would like to talk to us, please join those calls and give us feedback. And that is the end of my talk. So, questions?
Okay, so I have a quick question.
Yeah.
So you have many people contributing on this. I think it's impressive work. What I would be interested would be a formal description of how this thing is supposed to work. Do you have plans to work on this?
Yeah, I believe there are some people interested. I'm very interested in doing more formal verification for this. In particular, I mean, it's often very hard to get a handle on exactly how LWT is scheduling things. So we have informal descriptions in like all the. I mean, you're talking about the fiber scheduling. So each domain, for example, has a queue of runnable processes, and we have descriptions like fiber.yield says the current process is suspended and it's moved to the end of the queue. So we do specify deterministically exactly what happens, and there are people working on a formal specification of that, I believe. I don't know how far they've got with that. I think the main thing they find is trying to formalize cancellation, which is always a bit of a tricky aspect. But yeah, it should all be completely deterministic. And if you find a behavior and you think, I can't see from the documentation what should happen when it does this, that's a bug in the documentation, and please report it.
Okay, thanks. Yes, one quick question, then we have to switch to the next talk.
Hi. So I saw recently Casey published a library to try to make various schedulers interact reasonably, let's put it like that. One thing that I would like is the ability to, well, basically extend what we have here with a new effect that interacts with the scheduler in various ways. So the use case I have for that is we recently made an actor library for OCaML, and it needs to interact with the scheduler, but I do not want to use a different feature library, because that, I mean, why? Why would I do that? So,
well, I don't know
you
what
have IDs.
What we found is that those three effects seem to cover basically everything, because all the backends are just using those three. So I'm not quite sure what particular function you need from it. I'd have to have a look and see exactly what it's trying to do, but I don't see any reason in principle why you'd need a new. I mean, we use effects basically for scheduling. So if your fiber needs to switch to another fiber, you need an effect. If you want to get information about the current fiber, you need an effect. And usually you can build everything else you want on top of those two sort of primitives. So I'm not sure what it needs. Yeah, I'd be interested.
Okay, so you should take the rest of the questions offline. Let's thank Thomas again.
Great, thank you.